This is a video for Friday's lesson, Solving Exponentials Day 1. You can pause the video now and copy down this example if you want. What we're trying to solve today is an exponential function, so we're doing the reverse of what we did the last 2 days when we solved logarithms. We're going to use a similar approach. An exponential function, once again, has a base number and x is in the exponent. We're going to start with a very simple one. And we solve exponentials by taking the logarithm of both sides. You know that exponentials and logarithms are inverses of each other. So, since I have an exponential, I'm going to use a logarithm to cancel out the exponential in order to solve it. So, we are going to take the log of both sides, and we're going to use log base 2 since it is an exponential in base 2. So, I'm going to take both sides, the 2 to the x power and the 7. And I'm going to do log base 2 of 2 to the x equals log base 2 of 7. So we take the log of both sides. Now on this left side, I'm taking log base 2 of the exponential base 2. So a log base 2, exponential base 2, those are inverses. They undo each other. Leaves me with just x. Log base 2 of 7 is what x is equal to. Now we're going to use the change of base formula, so log of 7 divided by the log of the base number, which is 2. Log of 7 divided by log of 2, which is 2.8074. Let's do one with a few more steps. Looking at 4 to the 3x minus 1, so there's your exponential function. And then we have a minus 5, that's an outside number, equals 20. So we follow reverse order of operations, which means I need to add and subtract anything first. So I'm going to add this 5 over. Makes 25. Now I'm ready to get rid of this exponential. Dealing with the exponent step, we get rid of the exponential by taking the log of both sides. So since this is an exponential base 4, the base number for the exponential is 4, I'm going to use log base 4. So I'm going to take log base 4 of both sides. On the left side, log base 4 of an exponential in base 4, these undo each other. In other words, these cancel each other out. So I'm left with 3x minus 1. Now someone asked me one point in the last unit, how does that work when we use this property in the last unit? Because this is an exponent, how does it all of a sudden just become a regular expression? Well, you know the property of exponents says that any exponents of a logarithm can come in front and become a coefficient. So that's why the 3x minus 1 just becomes a regular 3x minus 1 when those logarithms cancel out. And on the right side I have log base 4 of 25. So when I run that through the calculator, log of 25 divided by log of 4, I get this decimal. And then we solve for x. Add 1, divide by 3, and there's x. Last example, I have a 7 being multiplied by e, so now we're dealing with a base e, natural base, raised to the 5x power plus 3 equals 80. I have two outside numbers being added here and being multiplied here. So we're going to start with those two. We start by subtracting 3 first from 80, which is 77. Then I'm going to divide by 7 on both sides. It gives me 11. So now I'm to the exponent part. This is my exponential in base e. And we know that a logarithm in base e is the natural log ln. That's log base e. So the inverse of exponential base e is ln log base e. So we're going to take the natural log ln of both sides. Ln of e to the 5x, that's one of our properties, just equals 5x. The natural log and the base e undo each other. On the right side, natural log of 11, divide by 5, and there's your final answer. Now as far as checking, we don't need to check any of these because we know that for all exponentials, the domain is all real numbers. It goes to the right forever, goes to the left forever. There is no restrictions on x. So these will work. So you don't need to check them. Make sure you complete the homework for this section as well.